Hello YouTubers, bringing you a quick video on Matlab today. The purpose of this video is just to give you a quick introduction, but by the time we're done here I'll create a script, we'll create a quick function, and I'll even go over some basic plotting techniques. Before we get started, why do a video on Matlab? I can tell you that if you're a mathematics student or maybe an undergrad engineering student, you're probably going to have some exposure to Matlab at some point. I'm a grad level math finance student right now, and we use Matlab quite a bit. Matlab is incredibly powerful, and if I were given a task maybe to just compute or analyze some data, Matlab would be my go-to language for sure at this point. So let's actually get into some coding here so you can see what Matlab actually resembles. The first thing, once you start Matlab up, you're going to see a command window here, and this is very similar to Python. If you've ever done coding in Python, virtually most of the Matlab language matches the syntax from Python, which is great. In fact, if you want a variable, we can just say a equals 5, hit enter, and it provides us our output here. It says a is 5, and we also get to see the variables on the right side, and it will keep track and just keep adding them down here as we make more and more variables. But now, this is called Matlab. Matlab is short for Matrix Laboratory, so let's create some matrices. Let's create a B, and B will be a 1 by 5 vector. So 1, 2, 3, 4, 5. There we go. We see it show up over here. It even gives us the value of all the elements. And maybe we wanted to create 3 by 1 instead of a 1 by 5. Well, if we want to make C a 3 by 1, then we just use semicolons instead of commas. So 1, 2, 3, and now C is a 3 by 1. But now the real strength of Matlab is our ability to now perform operations on these matrices, or really vectors, that we have here. So maybe we just want to square every element in C. Then we could say C squared. Now this period here represents element-wise operation. So we're saying for every element in C, square them all. And if we hit enter, there we go, they're all squared. And as you can imagine, other operations follow in a similar manner. Maybe you want to multiply, divide, any of your other operations. You can still do element-wise operation, and then you can also do things like dot products, cross products very easily in here. You can do inverse very easily of a full maybe 4 by 4 matrix. I'm not going to cover all this, but it is of course all very possible. But okay, let's get away from the command window here. Let's go ahead and create a new script. So all we do is just click on new script up in the left, very easy. And now we essentially just have a blank window where we can type, and then rather than running and hitting enter as we did in the command window, now it's just similar to any other program that you might make in Java or Python, where you actually have to run it and then the results will appear in the command window. So let's go ahead and save this quickly, and then we'll get into some basic plotting. Okay. Now before we do anything, notice that our variables are still left over here. If we want to clear those out, you can just go to the command window at any time and just say clear, and that will clear out all of your variables. You can also put that at the top with a semicolon so that each time you run this script, it will just automatically clear the variables and start fresh. Now the semicolon is not required. The semicolon in this language is not like Java or C++ where it will throw a syntax error if you leave it out. Here, the semicolon just suppresses output. Maybe you have something like a equals 5. If we run this now and we go ahead and run, it'll go to the command window, and here we have a is equal to 5. But now if we put a semicolon after this and we go ahead and run, nothing is going to happen. We'll run, it will create our variable a over here, but there will be no output. And while we're here, we should talk about this window over here as well. This window is incredibly useful, and it essentially is linked to some folder on your computer. Now you designate this folder, and it's useful because you can drop files in here, and you can open files from here, and you can import from Excel files in here. All you have to do is click on it and it will open it up, and then you can import. Very easy. But I'll just minimize this for now. And now let's get back to plotting. all I'm going to do is we'll just create a vector of maybe Let's say n is equal to 5,000, and let's just create a vector of 5,000 randoms. So we'll say rands equals rand n, which means we'll create a normal random variable, and we'll say 5,000 by 1. So 5,000 rows, 1 column. And let's just go ahead and run this so we can make sure everything's working fine. Yes, here's our rands, and just to check and make sure things are actually random, you can just go ahead and click on it and it will show it to you. There's our randoms, and this should go the whole way down to 5,000. Looks good. Let's close out of that. And now, how do we go ahead and plot our randoms then? It is so easy. All we say is plot rands. Plot rands, and I'm hitting F5 here to run. And it's running now. And here are our randoms. Now, it looks very cluttered because there are 5,000, but it looks good. 5,000 normal randoms. And you might be thinking, wow, that was really easy. But what about customization? Customization of the plot is incredibly simple as well. All you need to do is, maybe we want to add a title. So 5,000 randoms. And we can run that, and all it's going to do is just add a title, of course. And here we have it, 5,000 randoms. Very good. The X labels and the Y labels are very similar. Even the legend is very similar, and I'm not going to cover all that. But I will cover how to do subplots. Let's say you have two things that you want to plot, and you want to put them on the same actual figure, but you want two separate plots for them. Well, that's very easy too. Let's just back down n to make this easier. So let's say we have rands, and then let's make a rands 2, which will be rands 1, and let's just square everything in rands 1. Now, if we want to plot both of them on the same figure, then we're just going to use the subplot function. And the subplot function is incredibly simple as well. Just make sure you get rid of that 1, no 1 on rands. But to create subplot, all it is literally subplot. Then number of rows, I'll do 2 rows, number of columns, 1 column, and then which plot you're plotting right now. So we'll plot the first plot, and then we're just going to copy all this, paste it, create a second plot, and now this will be plot number 2. For plot number 2, we're going to be using rands 2 instead, and then we'll have 5,000 randoms, but this time they will be squared. So now let's go ahead and run this, and look at this beautiful, very easy to make figure we have. Plot 1, 5,000 randoms. Plot 2, 5,000 randoms squared. Just like that. Matlab is a great language. Now, obviously there's a lot more you can do with plots. I'm going to stop it here so we can talk about functions now. So let's get rid of all this, and let's go ahead and create a function. To do that, all you do is say new function. And let's rename it first. We'll say test function, save. And now, first, if you're wondering what a function is, well, a function in Matlab is just the same as a function in C++ or a method from Java. It's similar to a function from Python. So all those things, this is essentially Matlab's way of doing that. So I will tell you, if there's one thing I don't like about Matlab, it's how they force you to create functions. In Java, you can create several methods and shove them into one class file, and it's very handy. So you could have 20 functions or methods in one class. Matlab forces you to have one main function in every function file. You noticed already that when we went to new, we had to create a whole new file for a function that gets this .m extension. So I'd say if there's one downfall, that's one of the things that I do not like. But now, how do we actually create this function? Let's just say we want to create the simple usual demo function of a, b, and then we're going to return c equals a plus b, and then we'll just end up returning c. Nice sum function is usually nice to start with. So this is going to be the structure. It always has this reserved word function. This is where all of your outputs go. Now, I only have one output that's being returned. You could have many in here if you wanted C, D, E, all variables that are going to be returned. You could do that, so let's just stick with 1. This is the name. The name has to match the file name. Also not that big of a fan of that. So if you change this, you have to also change the file name. Then number of parameters, this is flexible, as many as you want, just separated by commas. So then all you need to do for the output is make sure that your output variable matches what you specified in the header up here. So we said that we will be returning C, then we have C down here, it's been created, and we're just saying that C is A plus B. So now we can go ahead and use this function as long as we just give it 2 parameters in our script. So let's go back to our script now, and I'll copy this first. And let's just say f is equal to test function 37. And let's run this. And now in our command window, 3 plus 7 should be 10, and look at that, there we have it, f is equal to 10. You can ignore this, I had an error earlier that was edited out. But yes, so there's our function, nice and handy. Now before I go here, I'll talk about a couple more things. The first one being the documentation for the associated functions in code of Matlab. Now, I think this documentation is very readable. I've used the documentation quite a bit with Java, which I really liked the format of that. But this format is very nice too. Here's an example of the augmented Dickey-Fuller test function, the ADF test. If you want to look up what this is, maybe you're not familiar with the function in Matlab, you can just type in ADF test Matlab. It'll bring this link up. Then we can see that it returns H. It takes in a parameter Y. If you want to know what either of those are, there are hyperlinks here. We can just go to H, and it'll say H is 1 or 0, and it tells you what both of those things mean. I think the documentation is very readable. No real complaints there. And the last thing I'll talk about before I end here is how Matlab compares to other statistics-based languages. So, and by statistics-based languages, I just mean languages that have the capabilities to do some advanced statistical analysis. So let's compare Matlab to SAS. I've used SAS quite a bit in the past, and I have a playlist for SAS. What I like about Matlab over SAS is that Matlab gives you an incredible amount of flexibility. SAS almost restricts you a bit to using specific procedures, but with Matlab, it's really endless the possibilities that you can create, given that you can create your own functions so easily. Now, I do think that you need to have a lot more knowledge about Matlab in order to reach the point where you can match your output from SAS. So that's the downside. I've used Matlab quite a bit at this point, and I can tell you that if I have to do any financial analysis with large amounts of data, Matlab is my go-to by far, without question. So I hope you guys enjoy this video. Maybe you're an undergrad student, or a grad student. Maybe this at least just gave you a quick introduction to it. But thanks for watching.